Irodov question 1.72. Find the acceleration W of body 2 in the arrangement shown in figure if its mass is eta times as great as the mass of bar 1 and the angle that the inclined plane forms with the horizontal is equal to alpha. The masses of the pulleys and the threads as well as the friction are assumed to be negligible. Look into possible cases. Okay, this is an interesting one. So let's draw the diagram first. Let's say this is M1, this is M2. It's given that M2 is eta times M1. This angle is alpha. And this acceleration is W. We'll have to find W. Okay. Okay. Let's assume that this tension is T. This tension is also T then because it's the same string. This tension is T dashed. So this tension is also T dashed. Okay. Now we'll talk about something called constraint motion. Now, when you have a complex pulley arrangement like this, it often gets confusing. So, this type of motion is called constraint motion. And one thing you have to remember is work done, the total work done by all the tension forces is always equals to 0 in this kind of situation. So, T times x, where x is the displacement for all the masses involved, this will be equal to 0. Okay. So, if that's the case, if we differentiate x couple of times, we can also say T times acceleration of the masses is equal to 0. So, for the moment, if I assume mass m1 is accelerating this way with acceleration a, m2 is accelerating down with acceleration w, then we can write t is this way, acceleration is that way. So, that's both are positive. So, Ta is this way. Now, this pulley has mass 0. So, this tension does not do any work on the pulley. However, this T dashed does some work because it is pulling up M2. But since T dashed is this way, W is the opposite way, this sum will be minus. So, T dashed W and this should be equal to 0. Okay. Now, the other thing is here we can see 2T dashed is balanced by T. That's the relation between T and T dashed. So, if I substitute that back here, so this becomes 2T dashed A minus T dashed W equals 0, or W is equal to 2A. Okay. So, whatever the acceleration of m1, W will be twice of that. So, in other words, we can write A is W by 2. Okay. So, we will frequently use this, the work done by tension is 0 in constraint motion to solve such kind of problems. And I will probably link up some of the related problems in the description of this video below, so you can look at that. Okay. All right. So, now that we have this, let's draw the free body diagram of M1 and M2. So, free body diagram of M1 will be M1G this side. We have, this is the inclined plane. So, normal reaction is like this. There is tension in the string like this. So, T, and we know that this angle is alpha. Okay, no friction. And for M2 is M2G T dashed, and M2 is going down with acceleration W, and M1 is going this way with acceleration W by 2. Okay. So now that we have that, we can write the equations of motion. So T minus M1G sine alpha, M1G is component in this direction, is responsible for M1's acceleration, which is M1 W by 2. From this one we can write M2G minus T dashed is M2W. Now we also have this relation of T and T dashed. So T we can write as, or let's multiply 2. So 2T minus 2M1G sine alpha equals M1W. Now 2T, T is 2T dashed. So 4T dashed minus 2M1G sine alpha equals M1W. Now if I multiply this with 4T dashed, it becomes 4M2G minus 4T dashed equals M4M2W. Equation 1, equation 2. Let's add equation 1 and 2. So T dash, 4T dash gets cancelled. So 4M2G minus 2M1G sine alpha gives me 4M2W plus M1W. Or we can write W M1 plus 4M2 equals, let's say we take 2G common, so 2M2 minus M1 sine alpha. Now W is equal to 2M2 minus M1 sine alpha by M1 plus 4M2 times 2G. Now if I divide numerator and denominator by M1, so 2M2 by M1 is 2 eta minus sine alpha by 1 plus 4 eta times 2G. So that is the value of W. Now some possible cases we can look at. Case 1 is when 2 eta minus sine alpha is greater than 0. So sine alpha is less than 2 eta. So if this is the case, then W is positive, so M2 goes downward. Okay. Case 2, when 2 eta minus sine alpha is less than 0, or sine alpha is greater than 2 eta, then M2 goes upward. Okay. And when case 3, 2 eta is equal to sine alpha, then system is in equilibrium. Why? Because then W will be 0 and both M1 and M2 will not be accelerating. Okay. So that is our answer.